So I'm about to test this wire in the actual SEM electron microscope, and I'll probably take off the little crocodile clip pieces, but I basically want to try and find out what this sample area is. So I can actually see that there's grooves on it, which we should hopefully be able to see in the SEM, and also we'll see what the composition is of the top material. I won't be able to detect what this is, the polymer part, but I'm wanting to see, is it the same material as this, which is in another video. Which should be the previous one to this one. And I am now looking at the crocodile clips. Again, I'm hoping that I can actually marry up the video so that what I'm saying is matching the video quite well. So if we actually just were to increase the magnification on the clip, one thing that you'll notice that if you look optically at a crocodile clip, it's often a little bit shinier, and that's because it's a much better polish. So if you looked at the tweezers earlier, you probably would have noticed that you probably would have actually noticed that so let me just focus this. Yeah, there we go, we've got a bit of rubbish. It's always nice to have a bit of rubbish that we can actually focus that on, and then I can quickly see which way to focus on. About there. And that's fine. Okay, so I'll just come down, and what we can see is it's a much finer polish than what we were seeing before. And if I just actually have a little look at my EDS, which is my elemental analysis, I can see it's nickel and chromium. There's a little bit of carbon kicking about, and that's probably these particles here that are appearing dark. If I just jump to actually a backscattered, which allows to see compositional difference, then you can see these are your carbon particles here and here and here, whereas you've got quite a nice uniform grey level, which is likely that the material is uniform. So if I was just to come back down, and I'm just gonna switch back to my secondary, I might actually go to reflected. Reflected is nice to actually see the fine surface details, but this is very, very well polished. I'm happy with this level of polish. You can see some little marks here for it, but they're very few and far between. They are dirty, but obviously that's to be expected. It's not exactly came from a clean environment, and these are probably the final polishing marks that haven't actually been removed. So let me just jump back to secondary, right, and let's have a moving it to a fast scan, so we can actually see the gap between them. So obviously you can't always grab stuff. So if I just jump my ruler, that's the information from before, and I'm just going to draw a line. So I'll say that gap. Okay, so that's about 200 microns gap here, 80 microns gap here. So 80 microns, that's about the size of a hair. So you probably wouldn't be able to actually take one of their hairs and actually grip it. I've got even less hair to grip. Okay, so let's close that, and let's just have a little look around. So that's obviously where it divides. So you can see that we've only got about 4 or 5 teeth. And then one side should be the lever. So here's the bolt. Let's just actually check, see if that's a different composition. No, it looks about the same. So I don't always need to run the element analysis. I can actually see it in the imaging. And so you can see up at the top, that's your lever point, and this is the insulated bit that was connected all around that part there. So I'm interested to just actually zoom up on this. I'm going to change it to backscattered again. This is what we call charging, and it's because this is an insulating the kit. But what I'm actually seeing is, if you've seen the tweezer video, we were having carbon with a little bit of oxygen and some barium sulfate. This, we've got carbon and oxygen. The oxygen is higher than before, but we've also got magnesium. Why the magnesium is getting used, I'm not sure. And I might actually have a little look at this under a low vacuum condition. But what I'm wanting to do now is jump over to my the magnet. So I'm not sure how strong a magnet this is going to be. So let's just jump over, and so we can see that's a circle of magnet. Let's auto contrast brightness it, and okay, so we've got the metal going around. So let's just, I'm just going to zoom up, give it a bit of a focus. This is me in backscattered mode. I might switch to secondary electron. Let me just move that, because I will likely look at this in a bit better. And okay, so I can basically sort of see, let's just do a slow scan just so you can see it a bit more, and I can basically see my surface here. Again, much better polished than the actual tweezers themselves, and I think it is looking relatively uniform. So let's change it to backscattered. I'll auto contrast brightness it. So basically just changing the contrast and brightness so it's a bit easier to see. And again, we've got a lot of black little spots. Likely that is going to be carbon, so let's actually switch that around, and I will analyze the black spots as well as the other stuff. So you can see I've got chromium iron and zinc. Now there's oxygen and there's carbon. So let's just first of all analyze the black area, and that is carbon, but you can see that I've got a fair amount of zinc there. If I just hold that there, there's also a fair amount of zinc. But you'll notice that the carbon disappears. So there's a little bit of oxygen as well. So if I'm sort of looking at that, it might be that the carbon signal is just on the surface, and therefore I'm analysing underneath, which is the zinc. The fact that I've got iron chromium, I'm sort of suspecting that the sample might be coated with some sort of zinc coating. So if I jump over to the, oh yeah, so here you can see there is let me just jump back to here. See how there's a slight brightness at this edge here, and that slight brightness, I'm just wondering if that's going to show up more as the chromium. So let's switch around again. Let's actually have a look at the EDS, and let's just do a point, and let's actually do yeah, it's richer in iron. I think that's more iron is exposed. So if I actually just check that area again, see that iron is smaller compared to this one, which is a bit higher. It's not a major bit. I could get percentages and do it a little bit more exact, but now I'm wanting to shift over and have a look at the magnet. Yeah, okay. So the magnet itself, if I just go fast, switch back to secondary just so you can actually see it. So there, see how you've got a nice ring around it here. I'm suspecting that it does have a coating on the top. I might need to actually dismantle one of these to actually see what the magnet actually is, because I suspect that there is something underneath it, and it's not a zinc magnet, and because I am still getting a zinc coating. I'm at about 2000 times magnification. Yeah, so I think we've got a coating going on here. So whatever the magnet is underneath, I think this is the coat. So oh yeah, so here's a nice little scratch. Also, the other reason that I'm thinking that it might be a coating is when I looked at it optically, I could actually see stripes on it. I'm not seeing the stripes here. If I go to my reflected, and I'm just going to auto-control brightness it, now the stripes were quite wide, but yeah, I can see, here you go, here's the stripes here. I don't know if that's obvious to you. So I wasn't able to really easily see it in the other one. Let's just go up, and I'm just gonna go up in magnification here. And I'm just gonna do slow. So I'm looking at this thing called reflected electron, which enhances the fine surface. And so here we go. You've got stripe, stripe, stripe. If we actually were to just do a quick measurement of it, this is just the measurements from earlier, and I just measure from here to here. That's about 400 microns. Here to here, it's close to the 400 microns again. So very quick measurement check. So obviously the pitch is about 400 microns, 0.4 millimeters. Okay, that was just a little bit more investigation. So I'm actually already seeing that it's shown up as zinc. It's got the sort of chromium. I'd need to check to see what's expected on magnet wise, but as I say, I think there might be a coating here, and knowing how the electron beam interacts with the sample, I suspect that the layer is at least 2-3 microns thick, because that's why I'm not seeing anything of what's underneath. So one thing that I could do is try and scrape off some of the layer. I'm just moving around just to see if I can actually see anything. So if it's a stronger magnet, it could be a neodynium magnet base. It might be a zinc based magnet. I need to check on that. I think it's more likely though it's a coating. So I'm just going around just to see, can I actually see anything? And as I'm doing this, I'm getting to see different bits. You can see actually the striations a little bit easier to see at this point. Let's just do a quick focus. So you now really get to see the surface roughness. Let's just put reflected on to really see it up, and you can see that surface roughness there. Okay, so this is what happens sometimes with the when you're actually investigating stuff. You make a little conclusion that it's sort of, oh, it's going to be one thing over the other. And so again, I was at half expecting maybe a neodynium magnet. It could still be some sort of rare earth metal magnet. It could be that it is a zinc based magnet. I might search that up before I post this video. But without, like, say, these techniques, you probably wouldn't be able to actually tell. So yeah, so let's take that sample out and we'll go from there. Okay, and that was a bit of a surprise. So I've still got the sample bent from when I actually put it into the SEM, and I was able to see the grooves, so that was fine. But it was the fact that it was zinc. Now, I have looked up, zinc is not magnetic, and so it's actually a zinc coating. So I thought, oh, I wonder if I could polish off some of the zinc coating and maybe see if it is neodymium at the bottom. I've decided not to do that because neodymium magnet dust can actually spontaneously ignite and could be quite dangerous, so I've decided not to do it. I might do something to it in a future video, and it depends if I get another bit of kit that shows up, which I might be able to safely get a cross section of it. And yeah, we also saw the actual clip up at the top. If there's anything else you'd like me to look at, then feel free to mention. If not, I'm going to be just finding random stuff that I will be looking at, mainly tools around, and also maybe some of the wood I've got in my workshop, and basically see how the different woods differ. So I've got basically pen blanks, as I'm going to be getting into pens turning at some point. Well, thank you for watching, and hope you had fun and found it entertaining as well.